So in the previous video, we have left our example question over here. So I'm just going to continue this and we are going to find the solution for it. So once we have this, we know that 2142 multiplied by an eigenvector v1 has to give us the 0 vector. So you can honestly go using a guess. Like, for example, if I'm multiplying 1 with -2, and if I add both of the components, the numerator is going to give me a 0. Not the numerator, the components on the top row. So if I try the same thing for the second row, if I'm multiplying 2 with -2, that'll give me -4, and when I add, I'm going to get a 0. So in most cases, you would be able to just guess through and get your eigenvector, but sometimes it's better, like, to actually perform the calculations. So over here, I can just take my v1 as 1 and -2. So if I multiply a minus lambda 1I with 1 and -2, then I'll get the 0 vector, right? And it can also be -1 or 2. Because remember, when you're multiplying an eigenvector by a constant, it is not a new eigenvector. It is still the same eigenvector, because all eigenvectors are linearly independent. So which means that when you're multiplying by a constant, it is not going to change the eigenvector. So when I'm multiplying by -1, the eigenvector still remains the same. That is one of the most important points we'll be covering a little later when we are solving the differential equations. So after we find the first eigenvector, we can then find the second eigenvector, and we can do a minus lambda 2I, right? And that would be, if you look at it, 1 minus 3, so that would be -2, 1, 4, and -2, right? So again, a minus lambda 2I times my second eigenvector, the corresponding one, has to give me the 0 vector. So my v2, or my second eigenvector, is going to be, so again, let's do it the same way. So if I'm taking 1 time of this, and if I multiply this column by 2, right? So I'll get -2 plus 2 into 1, that's 2, which would give me a 0 vector. And it works over here also. So my second eigenvector would just be 1, 2. Okay? So this is my second eigenvector. So this is how we have to find eigenvalues and eigenvectors. Similarly, when we have a 3 by 3 matrix, so you're just going to have one more diagonal, and hence you would end up with a cubic equation over here, and hence you will have 3 values for 3 eigenvalues, and hence corresponding 3 eigenvectors. So we'll be using this to solve some kind of differential equations, which would be starting from the next video, and how eigenvalues and eigenvectors affect the solution of a differential equation. Okay, thank you for watching.